All right, part two of this disaster. I'm just kidding. It's not too difficult. We only have about 4 more problems to go, so that's pretty cool. Let's move on. Let's talk about. We want to keep this in mind, right? This question number 5. We want to keep question number 5 in mind when we do the rest, because on certain questions, I'm looking at you, number 7. We need to adjust the PTO to get the most accurate information possible. So let's keep going on. Number 6 says a chisel plow is used in heavy soil conditions where resistance is 600 pounds per foot of width. Soil condition is firm. What size four-wheel drive tractor will needed to pull the chisel at a speed of 6 miles per hour if the chisel is 14 feet wide? Okay, there is a ton of info. So let's figure it out. So a chisel plow. Okay, fantastic. Let's move on to 600 pounds per foot of width. Soil is firm. Okay, fantastic. We're using a four-wheel drive tractor, 6 miles per hour, and chisel is 14 feet wide. Fantastic. So we got all of our information from the problem. Nothing else really matters. First thing we need to do is we need to figure out the drawbar power. So that equation's fairly simple. We already done this one. But the drawbar power is F times S divided by 375. So let's plug some stuff in. 600 times, we're at 6, divided by 375. Now, let's go, let me do the equation. We're at 9.6 drawbar power. We need to multiply that by 14 feet to be able to figure out how much horsepower the tractor needs. Be 134.4 horsepower. There are some things we didn't use. For example, we didn't need to go back to the charts to figure out certain things like our tractor or soil condition, right? We didn't really need to figure out any sort of draft resistance, that sort of thing, right? Chisel plow is the first one, what type or what the speed is typically, that sort of thing. We didn't really need to do that because all it's asking is what size tractor that I need. And right now I just need a tractor capable of 134.4 horsepower. It's the only kind of tractor I need. Okay, let's go to number 7. Number 7's, it's not as long as number 8. Number 7's actually easier to keep in mind or easier to actually accomplish. So it's scary, right? Because it's kind of long, but it's not really scary. So let's go through the kind of information that we need. So you have a two-wheel drive tractor rated at 100 PTO horsepower. Fantastic. And want to buy a moldboard plow. You will plow 8 inches deep. Moldboard. This is those John Deere looking plows that Mr. Deere created. You will plow 8 inches deep with most of the soil being a tilled condition. We got tilled soil. And the tractor is, we're going to assume firm conditions for the tractor. So the tractor's driving on firm conditions. It is leaving tilled conditions for the plow to drive on. The plow's going to have to deal with a tilled soil. The tractor's going to have to deal with a firm soil. And we'll kind of look at what that means here in a minute. So, let's move on and figure out exactly what we need. So first we need to figure out the horsepower of the tractor, the actual horsepower, because this isn't the actual horsepower, right? That's just your PTO horsepower. But when you go through and you go through the tilled soil, like in question number 5, you have to adjust this horsepower. So let's go back real quick to our handy little chart. 2-wheel drive tractor on firm soil is 61%. So we need to take 100, multiply that by 0.61, and that will give us 61 PTO horsepower. Fantastic. So that's our actual horsepower. Now we can take our actual horsepower, 61, and divide that by the power needed, or the drawbar power from the moldboard plow. The way we find this is we go back to our little template and we see we have a moldboard plow right here. Looks like drawbar horsepower for coarse, because remember, tilled soil means the soil has already been worked up and it's not fine, it's kind of coarse soil, already been loose. So drawbar power is 8 horsepower per foot. So we take our PTO horsepower, we divide it by our drawbar horsepower, and we get the answer to this equation, which is 7.625 feet. That is going to be the size of plow that we are going to buy. We don't need to worry about too much about PTO or horsepower, because a moldboard plow doesn't have any moving parts. Well, some of them have hydraulic auxiliaries that lift or move the wheels, but there's no real PTO needed for it. So we just need to know how big plow we can have so we can actually move through. Okay, number 8. Number 8's kind of long. So we have 400 acres of land. All we're doing is finding information right now. 400 acres planned for wheat seeding, and we must go over the tilled ground. Okay, so the ground's tilled twice. Okay, so we really have 800 acres of land. Weird. In 16 working days. I wonder what working days is. I wonder if that's 8 hours. Let's keep going. We'll figure that one out in a minute. With a tillage tool that has 300 pounds of resistance. So that's 300 pounds of resistance per foot. That's our draft, right? Assuming that it needs to be pulled at 5 miles per hour. What size tool and four-wheel auxiliary driven tractor would be needed? Oh, here we go. So we work 8 hours a day, and we're going to assume that field efficiency is 80%. Fantastic. Got all of our information. Okay? So let's figure out how many. First off, we got to figure out some details about this, like how many acres per mile can they do, or how many acres per hour, I should say, can they do. So let's figure out how many hours they need in a day. 16. It's not divided, it's times 8, because they're doing 1 day is 8 hours. There's 16 days. That is 128. Fantastic. Then what we do is we need to figure out how many acres per hour they need to do. So 800 divided by 128. We're at 6.25 acres per hour. Great. Okay, great. Now, we need to do something else, right? We just figured out how many acres per hour we can do. Now we need to figure out our horsepower that we need. So to find horsepower, we're taking our resistance poundage, our draft, we're going to multiply it by our miles per hour, divide by 375, and that will give us an even 4 horsepower. Fantastic. Right, so real quick, we already have enough information to figure out what tillage tool we need. It's going to pull 300 pounds at 5 miles per hour with 4 horsepower. Let's go back to our chart. We already figured out what we need to do. And we're going to look at this chart, right? 300 pounds at 5 miles per hour, 4 horsepower. So, tandem disc Harlow, 300 pounds. Perfect. That's 5.5 miles per hour and 4.4. Not quite exactly what we're going to need. We're going to run it exactly at 5 and exactly at 4. Let's keep going. We'll see what we can find. 300. Oh, one-way disc on medium soil. 300 miles per hour. Or not 300 miles. Oh, Jesus. 300 feet is our draft. 5 miles per hour and 4 miles per hour. That's incredible. That is exactly what we need. So the type of tool we were going to use is a one-way disc. Fantastic. Yeah, spelled it right. Yep. Okay, so now we need to figure out a couple more things. How big's this disc? Also, what kind of tractor do we need to pull this disc? So let's figure out width of the disc first. So width of the disc, what's going to happen is we are going to take our acres per hour, which is 6.25. We are going to multiply this. There is a constant, so we call it a constant value. That is always going to be the same no matter what width you're trying to find with this equation. It's almost like 375, how that's constant in that equation. We also have a constant, and that one is 825. Then we want to take that, divide that by our speed, which is 5 miles per hour. And that would give us, did one thing wrong. It's my bad. We need to also multiply our efficiency. So we need to multiply 100 over 70. So let's do this again. 6.25 times 8.25 divided by 5 multiplied by 0.70. Oh no! Field efficiency is 80. Read that wrong. Multiply by 0.80, and that would give us 8.25 feet. So we are using 8 1/4 foot one-way disc. Fantastic. So now we need to figure out what kind of tractor we need for this. So let's do that right now. So we take 8.25, multiply that by our speed, which is 4, with speed, and that will give us a usable horsepower of 33 foot-pounds, right, of horsepower or feet. Then we take that 33 and we need to multiply it by a firm field condition, because it's firm, right? This is firm conditions. So we go back to our little chart and we look at what is technically considered firm for four-wheel auxiliary drive, which is 0.65. So, oh, sorry, not firm. One thing, it didn't look right. My bad. One thing is, we're going over twice. We're going over the tilled soil twice. So it's actually going to be tilled conditions for this one. Because you're going over, the tractor's going to be driving in tilled conditions, right? So if you till once and you till again, the tractor's going to be driving in tilled conditions. Even if it is firm and you till it one pass, the second pass is going to be tilled. So you have to assume tilled for the whole thing. So you take that, and that's actually, you actually either multiply it by 0.62 or you can do 1.61, doesn't matter. For this sort of equation, I would do 1.61. It's actually going to be the same. And you're going to get 53.13 usable PTO. So I need a 53 PTO horsepowered front wheel drive tractor with a 8.25 one-way disc. Please. That is the answer to that extremely long question. Question number 9. Why does it require more horsepower in soft soil to pull the same implement than firm soil? 2 words, wheel slippage, right? Your wheels, I like this picture because it does a great job at it. Look at the amount of dust that comes behind firm soil. Not a whole lot, right? More dust because the soil is not as packed down, so it's a little bit harder, and then a lot of dust coming out of the soft or sandy soil. It's almost like running in sand. If you've ever been to the beach and ran in the sand, it is harder and takes more energy to run in that sand. So wheel slippage, that is the reason why we use more horsepower. I hope you guys enjoyed learning a little bit. Please let me know, or let Miss Marino know if you have any questions that we can answer. Thank you guys.